right, let's do the staircase problem. So this is a classic dynamic programming problem, and once you get the hang of it, it's actually very easy. It just takes a second to kind of get the idea of it. Now, the first thing I always do when doing problems is I just try to work it out in my head. Forget Python, forget Java, forget the computer, forget, Big O. Just do I actually understand the problem? Like, if I had a pen and a piece of paper, could I just, do the problem? Because that way I would know whether or not I actually got it. All right, so you have steps, you have a staircase, and the idea is you can get to the top of the staircase, but you can only take one step at a time or two steps at a time. Okay, so you can go up a step, one by one, or you can take one big step and do two steps at a time. So those are your options. How many ways can you get to the top? So let's think about it this way. So let's say that the bottom is 0, right? I'm at 0. I could take a step at a time. I could take one step, and then take another step, and then take another step. All right, so that's one way I could get to the top of the stairs. One step at a time until I reach the top. Or, let me kind of get rid of these. Oops, don't want that. Another way I could handle this is I could take a big step. So I could take a big step like this, go from here all the way to here. All right, and then take one step here. So this is 2, and this is 1, right? So I could get the right color, 2, and then 1. Nice. All right, or, okay, I also could just as well take one step and then a big step. So one step and then a big 2-step. Okay, that's also possible. So how many different ways can I get up to the top of the staircase? 3. 1, 2, 3. There's 3 different ways I can get to the top of the staircase given my movement restrictions. Now, how are we going to figure this out? Well, there's a little trick to it, all right? And again, I like the trick to this problem because it is kind of cool. It's the way you think about it. So a lot of times with solving problems, it's more about the way you think about the problem. And again, doing these problems and practicing this trains your mind to think maybe not so linearly. Instead of picturing myself at the bottom of the stairs, let me picture myself at the top of the stairs. All right, so I'm going to reposition myself here. I'm going to put myself here. All right, let's say I'm already at the top. All right, I'm at the top of the mountain. How did I get here? All right, how did I get to the top of the stairs? Okay, how did I get in this position? Let's hit the rewind button. All right, we're going to rewind, okay, for a second. All right, we're going to picture the rewind button. And where must I have been before I got here? Okay, I'm at the top of the stairs. I'm going to rewind one frame. Okay, we're going to rewind one singular frame. Where could I have been? If you think about it, there's only 2 options. Either before I got to the top of the stairs, I was here. Or I could have also been here. Correct? I could not have been here one step before. Again, I'm going to rewind one frame. Not 2 frames, not 3 frames, just one previous frame. So either I was on step number 2 and took one step over to step number 3, or I was here on step number 1, and then I had 2 options. I could have either taken a big step or taken 2 smaller steps. Notice how the number of ways I got to the top is the sum of how I got to the step before and how I got to the step to 2 steps before. Okay, it's the sum of these 2. Okay, either I was on the previous step or I was 2 steps before. I could not have been any earlier. I couldn't have been at any other place, right? Because I can't take 3 steps at a time. So those are my options. I either was on 2, went up 1, or I was on 1, and then if I'm on 1, I actually 2 options. I could take 2 little steps or 1 big step, either which one. So since that's the case, then really, if I'm at the top of the stairs, I could always look behind me and say, okay, cool. How many ways could I have gone to get to step number 2, and how many ways could I have gone to get to step number 1? Those 2 together combined will be the pieces, right? Because I either was here before or here before. So since I could have been either of these places, the sum of the number of ways that I got to either of these 2 places will give me the number of ways I got to this place. Okay, there's a very basic idea in mathematics about wholes and parts. All right, the whole is the sum of its parts. And that's very helpful in thinking about a lot of programming problems because they really boil down to math a lot. All right, so if you get it, I'm going to reiterate this. If you're at the top of the staircase, then if you look at the previous step before you got here, you were either one step before or two steps before, logically. All right, so therefore, the number of ways you can get to the top, right, can be broken up into two pieces. It's the number of ways you got to the step before and the number of ways you got to two steps before. Those are the two parts, all right? Those are either which one you could have been in the previous step. If we combine those, then we get the number of ways you could have gotten to the top step, which is the whole. The two previous parts are the parts, the top is the whole. All right, so how do we break this down in code? So in code, what we're going to do is going to look something a little bit like this. All right, got all that stuff out of the way. Basically, what I have to do in code is say for any given I, and let's just say I is a step, so we'll just say like stairs at I. The number I could have gotten there is equal to stairs at I minus 1, which is the previous step, plus stairs at I minus 2, which is two steps before. All right, well, Jonathan, like, what about like at the very beginning? Like how are we going to know these subproblems, right? Because this is a subproblem, and this is a subproblem. We could use recursion, but with dynamic programming, instead we're going to build up. What do we know? Again, we still have to think about base cases in dynamic programming. What's like the smallest thing I know, the smallest problem? Well, the easiest problem or the smallest problem would be, hey, what if you had no stairs? Okay, how many ways can you go up no stairs? Jonathan, that's a ridiculous question. If there's no staircase, you can't go anywhere. Right, so there's 0 ways to go up a staircase with no steps. Okay, there's nowhere to go. There's no steps. You can't do anything. Okay, cool. Well, I know that. What about if my staircase had 1 step? If my staircase had 1 step, what are my options? Well, you can only take 1 step, right? We can't overshoot it, so we have 1 step. Okay, what about a staircase with 2 steps? Well, then I have 2 options. I either take 1 step, then another step, or I take 1 big step. So there's 2 options. These are my base cases. Okay, I know these. I can reason through that. Then I can use this equation that I have here to do the rest. I can fill in the rest using this equation because I could start with these numbers and then calculate every other number, okay, moving forward, because I have I at the, for example, this one right here at 3, it will equal I minus 1, which is 2, plus I minus 2, which is 1. See how that works? And then once I add them, I'll get the next number, then the next number, then the next number, and it'll go all the way down. Let's see what this would look like in code using Python. Hi, my name is Jonathan Hopp, and if you're enjoying this tutorial, I invite you to visit my website, codingyourcareer.com. I've got courses on Java, JavaScript, TypeScript, and all of the famous frameworks like React and Angular, the kind of things you'll need in order to break into the world of tech and get the knowledge that you need. It's even great for people who are already in tech and want to like level up their skills. So it's codingyourcareer.com. Let's continue with the tutorial. All right, so the code for this problem is actually very simple. It doesn't actually take too much to do. It's only a few lines, so that's good. All right, so since this is dynamic programming, we're going to start from the bottom up. We're going to figure out our base cases, and then we're going to move up from there, calculate based on those. We're not going to do like recursive, where recursive's like, hey, here's the whole hamburger, and then, or here's the whole chocolate bar. You break off your piece, and then you hand the rest of it to somebody else to figure out what to do with it. In this case, we're going to start with what we know and work up to what we don't know. So let's have a table, and we're going to start with what we know. If we had a staircase with no steps, then there is 0 ways to go up it because there's no steps. If the staircase had 1 step, then there is 1 way to go up it because you can only, that's it, you go up one step. You can't overshoot it. If the staircase has 2 steps, then either you take 1 big step, 2 at a time, or you take one step and then one step. Okay, that's how you got there. From here, we've got the first three, so everything hereafter we can just calculate. We can just do some math, calculate it, and then go up from here. So as you can see, we built our base cases, and then everything else will iteratively, okay, build from these. Well, how do you do that, Jonathan? Well, we're gonna do a for loop. Iterative is kind of like this, like when you hear the word iterative, that should be a signal in your brain for loop. Like, I'm gonna like loop through things. Okay, what are we gonna loop through? For I in range, starting at 3, because we already got the indexes 0 through 2, and we're gonna go up to steps plus 1. Why steps plus 1? Because in Python, range goes up to the second number, but does not include it. I want to include the top of the staircase. I need to do that. All right. Any given, so we have table, right? So we'll do table, all right, dot append, right? Because we're gonna add values to the end of this list. And then what we're going to do is we're going to say, okay, cool. Well, what number how do we calculate the next number in the table? You take the step before, table at I minus 1, and add it to the step 2 before. So if you get 2 steps before. The number of ways that you got to the previous step plus the number of ways you got to the step before that. These are the two parts, and combined, they're the number of ways you get to the top of the stairs, however many stairs there are. And so we're going to calculate. So, for example, it took me 2 ways. There's 2 ways I can get to the second step, and there's 1 way I get to the first step. Combine those, I get 3. Then the next is 5. Then the next is 8. All right. So you'll notice that every step is just the sum of the sum of the ways to get to the previous 2 steps. After that, all you got to do is just return the table for the steps you want. All right. Let's give this a shot. All right, there's 5 ways to get to up a staircase with 4 different steps. Okay, so you could either take 1, 1, 1, 1, or you could take 1, 2, 1, right? You could also do 1, 1, 2. That's another way you could do it. All right, 2, 1, 1, or 2 and 2. Okay, 1, 2, 3, 4, 5. There's 5 different ways to go up a staircase with 4 steps. So it looks like we got it correct. All right, as you can see, like the code is not that bad, right? It's just a for loop and then a list, and then we just add to the list as we iterate. The main conceptual part of this problem is holes and parts. Okay, getting to the top of the staircase can be broken down into 2 smaller parts: the step before and 2 steps before. Once you get that, once you understand that those are the 2 parts, and being at the top of the staircase is a hole, is a different way of looking at the problem. Most people would think about how do I do it, like if I'm at the bottom of the staircase and go up. They don't think, what if I'm already at the top of the staircase? How did I get there? That's the key shift in thinking that I want you to kind of do, because dynamic programming will oftentimes, the way you approach them is think about the end result and how did you get there, all right? And once you figure out that, usually most dynamic programming problems are actually pretty easy.